Okay, let's proceed to our solid geometry. So we will be talking about three-dimensional figures here, applying the concept of plane geometry, but this time into three-dimensional figures naman siya. Alright? So we have our first problem here. So as I discuss the problems, doon ko na lang din ipapasok yung mga concepts that you need to understand. Okay? So we have here a trough has a trapezoidal ends which lie in parallel planes. The top of the trough is a horizontal rectangle 6 feet by 16 feet, and the depth of the trough is 4 feet. How many cubic feet of water can it hold? How many cubic feet of water does it contain when the depth is 3 feet? And what is the area of the wet portion of this container at this height? Okay, so ang trough natin is ano yan, parang usually ngayon nakikita mo siya nalagyan ng mga tanim, di ba? Maraming naging plantita dahil sa COVID. So meron siyang rectangular ends, trapezoidal ends in this problem, for this problem. Tapos itong trapezoidal ends na to parallel yan sa isa't isa, such that it will form a rectangular figure on top, tapos rectangular figure din yan sa baba. Okay, so ganyan yung magiging itsura niya. Ito yung trapezoid na sinasabi, tapos ganyan. Ganyan yung itsura ng ating figure. And the top has a rectangular base down na 6 feet by 16 feet. And the depth of this trough is 4 feet in total. So this is an example of a three-dimensional figure na triangular prism, tawag sa kanya. Okay? How many cubic meters of water can it hold? So first question dito is the volume of water or the volume of this trough in general. Okay, letter B naman is what is the volume at depth is equal to 3 feet. And letter C, what is the wet portion? Wet portion at depth equals 3 feet. Alright? So first things first, letter A, the volume of water. Since makikita mo dito on all sides of this one, no? Sa lahat ng sections, trapezoid talaga siya. Itong trapezoid na to, all throughout the length, trapezoid talaga siya. So prismatic ang ating figure dito. And if it is a prismatic figure, what you can do to get the volume is to get the area of the base. Get the area of the base multiplied by the height of the prism. But in this case, since this is ganito yung itsura niya, and ang base niya is itong trapezoid, no? That's the consistent face kasi na makikita mo dyan. We can get siguro the area of the face, multiply natin by the length ng figure natin. Okay? So, volume for trapezoid is 1/2 base 1 plus base 2 times height. Okay, then mumultiply natin siya ngayon by the length. Alright? So, ayan na. Question pala muna, do we have a value na ba for our base dito sa baba? Okay, do we have a value dito sa base natin sa baba? Okay, lagyan natin siya ngayon ng value. Let's assume that this is, say, 4 feet dito sa ilalim. Okay, so 4 feet, syempre by 16 feet din ito ang papunta doon. Kasi constant naman yung length niya. So, given that one, we can now compute for our volume. That would be 1/2 times B1 natin is 6 plus B2 natin is 4. This 4 is itong nasa baba. Height natin is the depth na 4 feet ulit. And the length of this one is yung 16 feet. And volume natin would be, how much is this? Let me calculate first. We have 0.5 times 6 plus 4 times 4 times 16. That would give us 320. 320 cubic foot. So that's the answer for the first question. Now, next question naman natin is, what is the volume of water at depth is equal to 3? Depth is equal to 3. Let me draw the trapezoidal face here so that you would see what happens when the depth would be now equal to 3. Okay, ito na siya. Instead na 4 siya kanina, magiging 3 siya this time. Okay. 3 ito. And this would be 4. Take note, itong buong length na nasa taas, this is equal to 6 feet from our given. So, we need to find what is this parang water line length here. Kasi 3 feet na lang ang kanyang magiging length. No? So, kailangan natin siya gamitan ng ratio and proportion to get this portion here. Tama ba? How do we do that? We have, let's say this is variable z. So that we have 3 over z is equal to 4 over 6. That would give us a z value of, ilan to? 3 times 6 divided by 4 would be 4.5. 4.5 feet. 4.5 feet itong waterline section natin na yan. Alright? So, given na mayroon ka ng 4.5 feet dyan, you can now recompute for the volume of water at depth equal to 3 feet using the same thing na ginawa natin dito. What we will just change is the value of our base 1, which is in this time, it would be, ilan lang siya ngayon? This would be 4.5 plus yung base natin na nasa baba, still 4 feet ito. Okay, plus 4 times yung height natin, 3 feet siya. Alright, times the length, yung 16 feet. Length towards the parallel trapezoidal na face. So, we have 0.5 times 4.5 plus 4 times 3 times 16. That should be 204 cubic foot. So, this answers question B. Next question naman natin is, what is the volume of water when the depth is equal to 3? So, that's for letter B. And we need to draw the face of this trapezoid para maintindihan natin what happens to this face when the depth changes from 4 to 3. So, this would be, let's say, 3 feet depth natin. And ito naman ang 4 feet. Okay? Kanina, meron tayong 4 feet dito. Tapos, project ko siyang pag ganito, ha? Project natin siya upward. Itong total na to is 6. Right? This total thing here is 6. Itong buo. Okay. So, kung 6 ito, tapos 4 itong projection dito, 1 na lang tong side na to, and then 1 na lang din tong side na to. Lagay ko dyan, 1 and 1. So, ito surely from this point here to this point here, 4 din yan. Kailangan natin malaman ano tong from this point to that point. That will serve as x. So, by ratio and proportion gagamitin natin dyan. What we have here is 1, itong sobra, 1 tayo dyan, over the total height 4 is equal to x over the total height here, which is, how much is this? 3. So, that would give us an x value of 0.75 feet. Alright? So, pwede ko bang sabihin ngayon na x din ito sa kabila, no? So, that you have here x, 4, and x. And if we set that variable, itong from that point to this point, set ko siya ngayon as variable z natin, we can get z by 4 plus 2x. That would be equal to 5.5 feet. Itong Z na yan would serve as our new base 1 this time. Kasi kanina sa letter A, 6 yung base 1 natin. Okay? So with that being said, we can get our new volume now. And that would be how much? 1/2 of base 1, which is Z, 5.5. Plus base 2 natin, which is 4, itong nasa ilalim, times the height 3, times the length. Don't forget, we need to multiply it by the length because we are looking for a volume value here. So that would give us 0.5 times 5.5 plus 4 times 3 times 16. That would be 228 cubic foot. So this answers letter B. Letter C question, what is the wet portion at depth D? So that pertains now to our situation B. Okay, wala na, hindi na kasama yung letter A natin, no? At depth 3 na kasi yung pinag-uusapan dito. So let me erase this one first sa taas para makapag-compute tayo for letter C. And we are asked to get the wet portion. Ano daw yung portion ng trapezoid na yan ngayon na naka-slant, nababasa ng tubig. So if you look at the trough, ayan, titingnan mo tong trough na to, makikita mo itong portion na to sa harap at sa likod. Liitan ko lang si trapezoid. May makikita kang ganyan, no? This is at depth 3. Yan, so may wet portion dito na part. Dalawang trapezoid yan sa harap at sa likod. On the side part naman, may nakaslant dyan na rectangular figure yan. Kung titingnan mo, no? At depth 3, pantayin natin sila. Yan. At depth 3, ito yung magiging wet portion niya. And again, meron kang rectangular sa side and rectangular sa other side. And lastly, may makikita ka din sa bottom part. Huwag mo kakalimutan yan, no? Sa bottom part, wet portion din yung nandyan na part. Therefore, if we are to get the area of the wet portion, we have to get 2 areas of trapezoid, 2 areas of rectangle, dito yung nasa side, plus area of the bottom section. Alright. So, area ng trapezoid natin, na-compute na natin ang mga parts niya dito, di ba? So, meron na tayong, itong part na to is the area. Right? So, this would be area wet, 2 times 1/2, 5.5 plus 4, times 3. Hanggang dito lang. Tama? Tapos, meron tayong area ng dalawang rectangle. Ito yun. Surely, ang rectangle na to, length niya is 16. Tama? Okay. Ang question is, what would be the height of this rectangle? Ano tong height na gagamitin natin? Should I use 3 feet as the height? Yes or no? The answer is no. Because ang 3 feet kasi, if you look at this diagram here, ang 3 feet kasi is ito, mula dito, papunta dyan. Itong height na to, no? Kaya nga nai-label siya dyan. Pero what you can see on this side na nakaslant is itong side na to. Okay? Let's say that is Y. Ang Y mo is this height here. And that will be the value na gagamitin mo to compute for area wet. So we get Y first. Can I put Y na lang here? So Y natin is the square root of, by Pythagorean theorem ito, square root of 3 squared plus yung x squared natin na 0.75 squared. So taking this one, 3 squared plus 0.75 squared would give us 3.09. 3.09 feet. Okay? Itong side na to ang gagamitin ulit. So you put the 3.09 here, 0.09, plus the area of the rectangular bottom. That is obviously 4 feet in width and 16 feet in length. Okay? In total, that would be, let me compute it first. Okay, that should give us 191.38 cubic square foot area of the wet portion. Right? So, basic principles pa rin of plane geometry ang tutulong sa inyo to compute for solid geometry problems. We have here a horizontal cylindrical tank, closed cylindrical tank, measures 12 meters long and 5 meters in diameter. It has to contain water with a depth of 3 feet when the tank is lying in horizontal position. Find the height of water when it is in vertical position. So this one is 12 meters long and diameter measures 5 meters. And the diameter is 5 meters and the height of water is 3 meters. So that would be above our center line, right? Kasi ang kalahati nito is only 2.5. This is only 2.5 meters and the depth of our water level is at 3. So that's the water level, 3 meters. Okay, now ang question is, since this is lying on a horizontal position, what would be the height if this horizontal tank would be placed in an upright position such as this one? Alright? What would be this height of water here? Okay, so how are we going to get this one? First thing that you need to understand here is the tank is closed. Therefore, in any position, the volume of water won't change. Am I right? Volume of water on horizontal position should be equal to the volume of water in vertical position. And that's the key in solving this problem. So first things first, we need to identify what's the volume of water in this position. So as we can equate that to our volume on this vertical position. So how do we get this one? For this volume, what we need to do is area of the face again times the length. Because the face, this circular face here is dire-diretso yan hanggang dito sa end. Kaso nga lang, no, instead of this entire face, ang kailangan natin i-consider, we will only consider the face hanggang dito sa waterline portion. So, from this portion here, pababa. Okay? How are we going to do that one? To approach this problem, you need to draw this line here. Okay? Is it right to say na ito siya is equal to 2.5 as the radius? Yes. Diba? So, that would be 2.5. Let me erase the line here para di tayo malito. This would be 2.5. And this would be, how much would this be? That would be 0.5. 3 meters minus 2.5, this would give us 0.5 here. Okay. Now, you will have a triangular shape area at this portion. Draw ko siya ha. This is your 0.5, this is your waterline section, and this is 2.5. 0.5. Now, can we find the angle here? You can have that using your tangent function. The tangent of that angle, let's say that's angle theta, is equal to tangent is, oh, this is cosine, so I'm sorry. This is cosine of angle theta is equal to adjacent 0.5 over hypotenuse 2.5. So that would give us how much? The angle therefore is 78. Right? That is 78.46. Okay? Theta is 78.46 degrees. So if this is 78.46 degrees, this angle here should be 78.46 as well. Right? So, if dalawang values yan ng 76.48, can we now get the area of the face as area of the sector minus plus area of a triangle. Area of this sector here, yan, that's a part of a circle, that's a sector, plus these triangles here. Tama yun, di ba? Okay. How do we get the area of the sector? Area of the sector is pi r times the radius 2.5. That's pi r squared. That's the area of the circle, right? And then, iproportionate mo siya ngayon with this remaining angle here. Okay, times theta over 360. Wait, before we proceed with this one, let me write the formula para hindi kayo malito. Okay, this would be pi r squared. Instead of using theta, we use beta over 360. So as not to confuse you guys, so this would be this would be angle beta here. Itong nandito sa labas. Right? Plus area of the triangle, that would be 1/2 r squared sine of 2 theta. 1/2 AB sine theta. So 1/2 r and r sine of 2 angle theta in between. That would be pi 2.5 squared. Your angle beta is 360 minus 2 times 78.46. I hope you're getting that right. 360 yung buong bilog minus dalawang 78.46 divided by 360 for proportioning. Plus your 1/2 r is 2.5 squared sine of 2 times 78.46 degrees. Okay, that would be how much? 78. That's pi times 2.5 squared times, okay, that should give you 12.30 as area of the face. Okay, can I write it here? 12.30 square meters. Therefore, our volume would be 12.30, the area of the face, square meters, times the length of this tank, 12 meters. That would be, volume is 147.61 cubic meters. This is just the first part of our solution, getting the volume when it is horizontal. And that volume should be equal to the vertical volume. Let me erase this portion here. Right. So, volume vertical, in the upright position, the volume here is pi r squared times your height. Okay, our r here is still 2.5 because we're talking about the same tank. So, this would be pi times 2.5 squared times height, which is unknown. That's the height when it is upright. And that should be equal to 147.61. Computing that would give us a height of 7.52 meters. So when upright, this would be the height of water to satisfy this condition. Okay. Okay, this one is a problem about sphere. A sphere of radius 8 is 8 centimeters is cut by two parallel planes, one passing 2 cm from the center and the other 6 cm from the center. We need to find the volume of the frustum between two planes if both planes are on the same side of the center. And next question, letter B, we need to find the volume if both planes are on the same side from the center, and determine the area of the zone between the planes, and find the larger volume of the spherical frustum formed if only a single passing plane passes 3 cm from the center. Okay, so our problem looks like this one. I will draw a two-dimensional sphere na lang. Ganito yung itsura niya. And what was given was the radius of 8 centimeters. And we have, we are to pass a plane daw. To pass a plane 2 cm from the center and the other one 6 cm from the center. So let's say this one is your center and this would be our diameter. One plane is 2 cm from the center and the other one is 6 cm. So for the first part, we need to get the volume given that ang first daw na plane is on the other side and the other one na cutting plane naman natin is on the other side naman. So that means this would be yung 6 cm na sinasabi niya, and this would also be the other 2 cm na sinasabi ng problem. We are to find this volume here. Okay? Ayan, di ko lang muna siya isa-shade kasi i-draw natin yan dyan ngayon. So what we have here is actually the volume of a frustum of a sphere. Frustum of a sphere. Okay, alam natin ang sphere, di ba, is yung pang 3D talaga na bola, pang ganun. So, ayan siya. So, when we talk about frustum of a sphere, malalaman mong frustum ang tawag sa kanya, or ang ibang tawag din sa kanya is spherical segment. Okay? Spherical segment. Or frustum of a sphere. So, ang top nito, no, if you are to cut this one, you just imagine na lang, this is a watermelon. Watermelon which is a perfectly round watermelon. So, if you are to cut this portion of the watermelon and remove this portion here, what you will see on top of this one would be a circular section. Right? Makakakita ka ng circular section dito, as well as dito. And the largest circular section that you can see is actually when you cut it here dito sa diameter. Yan yung pinakamalaking bilog na makikita mo. So, I hope na i-imagine nyo ang nangyayari dito. Yan, no? So, pag frustum, dalawa kasi yung pwedeng mangyari dito, no? Meron tayong one base na frustum, or spherical segment, and the formula for one base natin is V is equal to pi h squared divided by 3r minus h. Alright? So, meron naman din tayong two bases. Yan, two bases naman natin, the volume would be pi h over 6 3a squared plus 3b squared plus h squared. Okay. Magiging one base siya if isang circular section lang yung makikita mo. So, just like this one, no? Since dalawang plane yung ipapass through mo dito and you are concerned with this inner portion of the sphere, basically, we have two bases here. Kasi may isang base doon which is a circular base and this one is another circular base. Kaya itong A and B dito, where A and B are the radius of the circular bases. Okay, radius siya ng circular bases. So, if you look at this one, ang A natin is itong distance na to. Yan. This could be our A. And ang B naman natin is ito siya. That is our variable B. So, ito yung gagamitin nating formula ngayon. Okay? Ang H naman natin, ma'am, ano yung magiging variable H? The H is the distance between the bases. Alright? Or this is the thickness. Ganun na lang, no? Thickness of the segment of your spherical segment. So, when we say thickness, perpendicular distance yan from the radius, or from the radii natin, no? So, that would be H. Yan yung magiging H value natin. So, if that is the case, we need to compute first for A and B because it's obvious already for letter A natin na problem that our H would be 6 plus 2 cm. That would be 8 centimeters. Question na lang ngayon is what would be A and what would be B. Take note that this one here is your radius, 8 centimeters. This as well is your radius, 8 centimeters. You know this distance, this is 6. You know this distance as well, that is 2. Therefore, you can get your A and B by Pythagorean theorem. Okay? So, by Pythagorean what do we have? We have 8 squared is equal to 2 squared plus A squared. You can get an A value there equal to how much? That would be 4 square root of 3. Okay? For B value naman, you have 8 squared dito as hypotenuse nito, and you have 6 squared plus A squared. So that would be 2 square root of 7. We have B equals 2 square root of 7. So that's it. And then, that would be direct substitution na kagad. So what's important dito sa topic na to is at least you get to see ano yung mga formulas that you can use for sphere and be familiar with it already. So as when you move to your board exam preparations or other preparations that you need to have, hindi na siya ganun kabago sa inyo. Because for civil engineering, as far as I can remember, this was discussed to us when we were still in first year. And you will take your board exam after a minimum of 5 years. So some others will take it after 7 years or so. So I can say na yung iba, limot mo na talaga. That's why we are having a review here. Okay? Ayan. Lagay ko siya dito ngayon, guys. Okay, this would be now pi. H natin is the height, the thickness, which is 8, divided by 6 from the formula. Yan, you have 3a squared, you have 4 square root of 3 squared, plus 3, 2 square root of 7 squared, plus h. H natin again is 8 squared. Okay, let me input that sa calculator and you try inputting that to yours as well. 3 times 4 square root of 3 squared plus okay. And I apologize for the little delay. I'm doing it myself lang kasi all of these things. Okay, so that should give you 1, 2, 2, 3. 1, 2, 2, 3.13 cm cubed. That's the volume of your spherical frustum if the two cutting planes would be on separate sides from the center. Alright. Now, moving to the next problem, letter B. What if both planes are on different sides of the center? Okay, baliktad pa lang ginawa ko. Teka. So, next question natin is what if find the volume of the frustum between two planes if both planes are on the same side of the center naman. On the same side naman. So what we need to do is, let me erase this one first. So as meron tayong space for our computation. This time, nasa same side sila. So we need to adjust our computation here. Teka lang ha, isulat ko pala yung value ng A natin. It was 4 square root of 3, if I remember it correctly. And B naman natin is 2 square root of 7 ba yun? Teka lang. Let me recall that for a while. 4 square root of 3 and 2 square root of 7. Okay, yan nga. Ayan. Kasi sa problem na to, sa next problem, ang magbabago lang dito is, ililipat mo siya on the other side. So, let me erase this one now. Ta-transfer natin ang cutting plane na isa dun sa parehong side kung saan natin ginawa yung una. Okay. Let me see. I-resin ko ngayon tong 6. Ang 6 na yun would be on that other side naman. So, eto ngayon yung isang cutting plane. Let me erase this broken line ha, para hindi tayo malito. Ito ngayon ang isang cutting plane natin. And, remember, ang distance na to ay 6 centimeters. So, if nasa same side sila, what you are concerned here now is ito. No? The space or the volume of the frustum between the two cutting planes. Alright? So, ano yung magbabago sa computation natin? The only thing that will change here is the value of H. So, from 8 centimeters kanina, kasi 6 plus 2 yun, this time, 6 minus 2 na tayo. This would be 4 centimeters thick na lang. Are you getting it? So, still, while computing this one, pareho pa din ang magiging value ng B. Nilipat mo lang siya onto the other side. Right? So, A and B would still be the same. So, computing question letter B, V on same side tayo. Ayan. So, this would be V is equal to pi. Still, 2 bases tayo kasi meron tayong circular section dito and dito dun sa cutting plane na to. Right? H natin this time would be 4. And you have 6 na V. And we have still 3, 4 square root of 3 plus 3 squared plus 3, 2 square root of 7 squared plus height natin this time 4 squared. So you will get a volume here. Let me compute that muna. Alright, that would give you 511. 511.03. Alright. This is in cubic centimeters. This is for letter B. Okay. Next question naman is determine the area of the zone between the planes. Area of the zone between the planes. Ano nga ba yung zone na sinasabi niya dito? Ayan na. So, si zone natin, meron tayong formula naman na sinusunod sa kanya. Pa-erasin ko muna sandali. Okay. Kung pag tinanong tayo ng volume, alam natin that we are looking for a 3D figure here. When we talk about zone, this is your surface area. Okay? Surface area of lateral surface area to be more accurate. Lateral surface area of a spherical frustum. So when I say lateral surface area, edi ito lang yun yung paligid niya. Kasi imagine niyo ulit yung watermelon. Watermelon is green on the outside and then red on the inside. So when we talk about volume, we are getting the amount of red matter inside that watermelon. But when we talk about zone, we are computing only for the green portion of that frustum. So basically, yung nasa palibot lang siya. No? So, ganito kasi yung magiging top view niyan pag naputol mo na siya. May circular section siya dyan, may circular section siya dito, and then may parang curved section siya dito because this is a portion of that sphere. And yung nasa paligid nito, as in yung green portion lang, you call that the zone. And when getting the zone, you use this formula. Yung 2 pi r h. Okay, so hindi siya madaling, hindi siya mahirap tandaan because 2 pi r is your circumference, as imo-multiply mo lang siya sa height. Alright? So, parang approximate lang siya na pagkuha. Ano? Kasi, parang similar siya sa cylinder. Diba? Halos cylindrical din kasi yung mabubuo nito. 2 pi r h. So, what we have here is, for the first situation kanina, lagay natin, no? H lang naman yung pinagkaiba nila. Zone nung kay A would be 2 pi. R natin is 8 and H natin kanina is 8 as well. Right? I hope nare-recall nyo pa yung first situation, yung nasa magkaibang plane sila. So, 8 times 8, you have 2 pi here. So, that's 128 pi. Pwede na, ito yung isagot natin. This is cm squared. 128 pi. For zone naman, nung B natin, this case here, we have still 2 pi r. So, r is still 8. H this time is 4 centimeters na lang. So, that would be, yan, that would be 64 pi. Ay, I'm sorry, kulang tayo ng pi dito. This should be 128 pi cm squared. And this should be 64 pi cm squared. So, that's how you get the zone. Okay? The formula are easy to familiarize for as long as you know ano yung term na yun. No? At least, when you move into your further preparations, hindi na kayo masyado ma-shock. What does it mean when you say a zone, a spherical frustum? At least you can imagine it on top of your mind. Right? So, to finish up this problem, we have letter D question. This one is for letter C. Both of these answers here. For letter D question, place ko to sa side na to. So, we are asked now to find the volume of the larger portion of the sphere if we are to pass a single plane 3 cm from the center. So, let me draw that one. Liitan ko na lang. We have a circle here and this is the center. And then, 3 cm from that, this one is the 3 cm part, we are to pass a plane. Okay, we need to determine the volume of the larger frustum. This one here. And that's the case that you will be using your H2, this one base formula. Alright. So actually, pwede mo pa naman gamitin yung 2 base dito. No? Kasi ang, di ba may A and B yun? So kukunin mo din yung isang radius dito. Ayan. And then yung gagamitin mong B is i-zero mo siya kasi wala ka namang circular section dito sa taas. But if you want, you can use this directly para mas mabilis ang magiging computation mo. So, since ang radius natin, don't forget, is 8 centimeters, you are to consider the thickness H sa computation mo as 8 centimeters plus 3 centimeters. So, that would be 11 centimeters. So, we use that one now. This would be pi. H is 11 squared over 3. You have here 3 times the radius 8 minus 11. That would give us our final answer for this last problem. And that is equal to, how much is this? 1647.24. 1647.24 cm cube. So these are our volume computations for spheres. What is the total surface area in square units of a spherical wedge with a diameter of 25 units and a dihedral angle of 36 degrees? So now this talks about spherical wedge. Kanina, pinag-usapan natin spherical segment and spherical zone. This one is spherical wedge. So if you can recall, I'll draw again a surface of a sphere here. Ang spherical segment, we can produce a spherical segment by passing a cutting plane here that is parallel to the diameter, right? On the horizontal diameter, no? Parang ganyan. Bibigay siya ng dalawang circular base. Ang spherical wedge naman is also a part of this sphere, but hinahati natin ang wedge natin in this manner. Okay, this is the axis that passes through the center of the sphere, and si wedge is just like this one. Okay, so if nasa top view kayo, you will see here a parang pointed na ganyan. Ganito ang hatian ng wedge. Okay, this one is the top view. So if you are familiar with the street food na watermelon, like it is sold on almost everywhere here in our city, no? Yung watermelon na parang smiley, right? You call that a spherical wedge for as long as nagpapass through siya dito sa gitna. So hatiin mo yung watermelon pag ganyan sa taas and then kukunin mo siya. That would give you a normal watermelon na slice. So, I will try to find something here sa aking, baka meron tayong makita para mas ma-imagine ng iba. Let me show you this type of, teka lang ha. Ayan, basta kung nai-imagine nyo, ganun siya. I can't see an example here. So, na-imagine nyo naman siguro, no? Ayan, just like this one. Let me show you sa ating video. Here, that's how a wedge looks like. Alright? So, that's it. And then, what are we going to do now is to get the area of, or the volume of this wedge. If you have a dihedral angle daw, which is equal to dihedral angle which is equal to 36 degrees. So you can see your 36 degrees here on top, and that's here also 36 degrees. Given also is our diameter. Diameter is 25 units. We need to get what? The total surface area. The total surface area. Okay, unknown. TSA of the wedge. Okay? Hindi lateral surface area ang tinatanong, but total surface area. So, that would be, if this is a watermelon, what we are looking for as the TSA here is the lateral area, the green part of our drawing. Okay, if naaalala niyo ulit, no? Ulit lang. Okay. So, if you look at this drawing here, you will see a green part there. And that has a thickness that you can see in this portion here. Alright? So, yun ang unang part ng surface area. As well as itong surface mismo na to, the red portion. That's part of the surface area of the wedge. So, you have a semicircle here and semicircle on the other side of this watermelon plus the green portion. Okay, I hope you are getting that. Two semicircles, two area of semicircles, and plus area of the lateral area. Okay, so how do we get the area of the semicircle? That's very easy. 2 times pi over 2, okay, semicircle, pi over 2 r squared, or pi over 2 r squared. So if the diameter is 25, therefore our radius is 12.5 units. So this would be 12.5 squared. That's for this portion. Ang lateral surface area naman natin is hindi nyo kailangan memoryahin kasi this is something very familiar to you. Okay? Do you remember the area of the sphere? Area of the sphere is 4 pi r squared. That's for the whole sphere. But since you are taking just a wedge of it, you need to have it proportional to how many degrees lang ang magiging dihedral angle niya. Alright? So that would be theta over 360, wherein theta here is the dihedral angle. So that would mean 4 pi r is 12.5 over 12.5 squared. Dihedral angle natin is 36 divided by the entire circular angle of this sphere, 360. So, naka-proportion lang tayo. So, that would mean our final answer would be how much? Let me compute that. You have okay, that should give you 687. 687.22 square units as the total surface area. So, take note nyo lang yung mismong tanong ha. Since total yung tinanong, that includes the two semicircles. If lateral surface area lang, itong portion lang na to ang magiging sagot natin. Alright? Alright. Okay, next question and last question about sphere. The area of the spherical lune is 20 centimeters squared, while the area of the sphere is 80 centimeters squared. Find the volume of the spherical wedge. So, similar kanina, spherical wedge ang pinag-uusapan, but it also mentions the word spherical lune. So, what is this spherical lune? This is actually the lateral area of the wedge. From our previous problem, you can recall we're talking about the watermelon, no? Watermelon, this is again how it looks like when you see a wedge. And spherical lune is the green portion. Okay, that's the lateral area. Yan. So the area of that lune is mentioned to be 20 square centimeters, and the area of the sphere, this pertains to the total surface area of the sphere, is 80 square centimeters. What is being asked here is, what is the volume of the wedge? Okay? Nasaan ba tong wedge? Where can you find this wedge? It's actually part of the problem. Kasi if there's a lune, there should be a wedge. So if this is the axis of our sphere, of the watermelon that we were talking about earlier, now we cut a little portion of this one, that would be your wedge. So if that's a watermelon, here are the seeds. And this is the green part. Okay? So, if this is a wedge, we are very much concerned of our dihedral angle. Here, angle theta. And area of this lune, yan, area of the lune kasi, we can compute that by 4 pi r squared times the dihedral angle over 360. Kasi kinukuha mo lang kung anong portion of that whole 360 degrees ang gagamitan mo or ang kukunan mo ng ang equivalent to the area of the loon. Tama ba? Kaya ka may theta over 360 dito to show the proportion. And remember, this portion here is equal yan sa area of the sphere. Do you recall? 4 pi r squared is the area of the sphere. Now, we can substitute our values here. 20 cm squared is the area of the loon, and 4 pi r squared equal to the area of the sphere is 80 centimeters squared. So, theta over 360. What you can first compute is your dihedral angle theta. And that is how much? That is 90. 90. So, if that's a 90 degree pala na sphere, 1/4 of the sphere ang hinahanap natin, no? The wedge is 1/4 of the sphere. So, if you will look at the top view, yan. Ito yung wedge na concern natin ngayon. Yan. Naka 90 degrees siya dyan. So, how are we going to get the volume of the wedge? That's the volume of the entire sphere, 4/3 pi r cubed times, again, theta over 360. Ganun mo siya kunin. Alright, we have the theta value already, but we don't have the exact value for our radius yet. So, we compute the value of our radius by getting the area of the sphere, which is 80, equal to 4 pi r squared. 80, the area of the sphere, 4 pi r squared. Diyan mo kukunin ngayon yung iyong radius. So, that would be 2.52. 2.52 centimeters. Okay? Substitute natin dito lahat ngayon so that we could finish up this problem and get the volume. Pi r is 2.52. Theta is 90 divided by the whole circle angle 360. So that would be, sorry, I forgot. Cube. There should be a cube there. So, that would give you 16.82 units cubic centimeters. Right. That's all for our sphere. So, let's talk about cone naman this time. Yan, very familiar sa atin ang cone kasi ice cream, right? Or party hat, that's conical in shape. Mount Mayon, Mount Fuji, that's cone. Okay, so we have a problem here. A right circular cone is to be made from a circular sector of radius 36 centimeters. The central angle is 200 degrees. Find the volume of the cone form. This is a very, very, very common board exam problem. So we have here this cone. Oh, it's not very conical. This is actually a sector. Sector of a circle. So we have a big circle. We cut out a pizza portion of it. And this one here is 200 degrees. It doesn't actually look like 200 degrees, but let's just say this angle is 200 degrees. And we have a radius of 36 centimeters. Alright, find the volume of the cone form. So we have here let me give you a quick this one. I'm finding a paper here. So as you can see, so say we have a paper that is like this. And assuming that this is parang cut out ng isang ganyan na shape, no, that's a circular sector. So, i-fold ko siya ng kaunti para magmukha siyang circular sector. Yan, assuming na pa-curve siyang pa ganyan. What we are doing here is i-roll mo siya. You need to roll it this way para magmukha siyang cone. Okay? So, if this is a perfect sector of a circle, just like the drawing, pag ni-roll mo siyang ganyan, that should look like a conical section na 3-dimensional. So, ito, parang i-convert mo siya into something like this. Familiar kayo na gawin yan sa mga party hats. Diba when you buy your party hats sa mga gift shops or party shops, naka 2-dimensional lang siya. And kayo na yung mag-roll sa kanyang pagganyan para mabuo siyang ganyan to become a party hat that you will place on top of your head. Right? So the question is, what is the volume of this cone? Alright? So what do we need to find here are the variables. So if you are to get the volume of this cone, this is area of the base, which is pi. In this case, let me denote this one as r sub o. So this should be pi r sub o squared. And that should have a 1/3 at the beginning because cone, may mga apex, na basta mga pyramid, mga cone, that should have a 1/3 here. Okay? Times our altitude h. And altitude is always measured from our apex, the highest point or the top vertex of that, perpendicular to r sub o. This is your altitude h. Okay? So, no question. How are we going to use the given from this portion? Itong r na to and itong 200. Ayan. Ang r ba na to would be your r sub o? Definitely not. Kaya nga, binago ko ang pag-denote. Ginawa ko siyang r sub o. Ang r na to would serve as your slant height here. Diba? Kasi kung ito yung radius, siya yung i-roll mong pa ganyan, magiging slant height siya. Ito yung equal to 36 centimeters. Right? So, we need to find either r sub o or h para makompute mo din yung isa pang unknown na variable. So, take note, dito, ano bang mangyayari dito sa ilalim, di ba? If ito yung total length, we call this one your arc length. Arc length S. Okay? And S, we can compute that by r theta, wherein your theta here is in radians. So, computing that S would give you 36 na r natin dito times 200. I-convert natin si 200 ngayon into radians. That would be pi over 180. So, S mo ngayon, your arc length would be 36 times 200 times pi over 180. That would give you 40 pi. 40 pi centimeters. Tama bang sabihin na itong S na to, pag inikot mo siyang paganyan, would be this entire distance here? Yes or no? Your answer should be yes. So, si arc length S mo pala from this drawing here is equal to the circumference C of this 3-dimensional figure here. And having known that this is your circumference, you would be able to compute for r sub o. Because you know your circumference C is 2 pi r sub o. Right? And that should be equal to S equal to 40 pi. So, computing your r sub o here, that would give you how much? Pi would be cancelled, divided by 2, that would be 20 centimeters. R sub o mo pala is 20 cm. And by Pythagorean theorem, Okay, you can get your h. That would be 36 squared is equal to 20 squared plus h squared. Your h therefore would be 36 squared minus 20 squared, and take the square root. That is 8 square root of 14. Putting everything together now, we have 1/3 pi r sub o is 20 squared, and your altitude h is 8 square root of 14. So that would be how much? Volume is equal to 1, 2, let me do that again. Alright, times 8 square root of 14. 12538. That's 12,538.41 cubic centimeters. Yan. So that's for a cone. Okay, our next problem is all about paraboloid. So I'll introduce this paraboloid kasi you can not only use this one on under solid geometry, but more importantly under fluid mechanics, the paraboloid of revolutions. So this one is, find the volume of one base paraboloid water basin having a diameter of 16 and an altitude of 32. Paraboloid with diameter of 16 meters and altitude h of 32 meters. So, ano bang itsura ng paraboloid? Actually, nafo-form mo yan usually sa fluid mechanics ko to nakakita tong topic na to eh. You know? So, meron kang cylinder, and then, ang paraboloid is a solid of revolution yan. Ganito yung itsura niya. Parabola siya na parang 3D kumbaga, na parabola. So, parang siyang, ano bang tawag yan? Menstrual cup, if you're familiar with that figure. Let me search the net so that you could see what a paraboloid looks like. So, like this one. Okay, this is a good picture of a paraboloid. That one. Yan. That's a paraboloid. So, on a flat surface, it looks like this one sa kanyang front view. Okay? So, sabi, meron daw siyang diameter, excluding this portion here, ha? Burahin natin. Pero, yan, napapasok mo kasi yan siya sa cylinder. Ganon. So, diameter is 16. So, radius natin would be, this would be, ano ba to? 8 meters, and our altitude here is 32 meters. Volume ng ating paraboloid is half of the volume of the circumscribing cylinder. Ulitin ko yung sinabi ko ha. Volume ng paraboloid is equal to 1/2 the volume of the circumscribing cylinder. Kaya kanina nag-draw ko ng cylinder. May imaginary cylinder siya na nakabalot sa kanya. And since ang cylinder, familiar kayo sa kanyang formula, di ba? Ano ba si cylinder? Area of the base, pi r squared, height. Ganun lang, di ba? So, 1/2 of that is the volume of your paraboloid. And that's what we're going to find for this problem. We have 1/2 here, pi here, r is 8 squared, and we have 32. Volume of paraboloid. That would be how much? 8 squared times 32 divided by 2. That would be 1,024 pi cubic meters. Or in decimal, na-multiply natin siya by pi. That is 3 to 16.99 cubic meters. Ayan. Okay. So, our next part is, let's talk about pyramids naman. So, pyramids. We built it on a solid rock. Sabi ng kanta, di ba? Like a pyramid, like a pyramid. Ganun daw, no? Okay. Ayan. So, we have here, calculate the lateral area, the surface area, and the volume of the truncated square pyramid whose larger base edge is 24 centimeters and smaller base edge 14 centimeters and whose lateral edge is 13 centimeters. So, idodraw natin ngayon yung sinasabi niya. Ito is parang, pag sinabi mo kasing truncated siya, truncated. Pag sinabi mo kasing, ayun na nga, truncated square pyramid or frustum of a square pyramid siya, pyramid din siya, pero hindi siya natuloy. Wala siyang apex, kumbaga. So, this would be, how do I draw this properly? Alright, let me, truncated pyramid. Para tong Toblerone na kinagatan mo. I-ano natin siya konti pala. Nag-ano tayo dito, call a friend. Yan. And then we have I hope you can imagine what I'm trying to draw here. This is the most challenging part of being a teacher. Hehehe. Alright. Ayan. I think that is kind of clear naman sa drawing. Ayan. That's a Toblerone na kinainan on top of it. Pyramid na hindi natuloy yung kanyang apex doon. So, ang sabi sa problem natin is that we have a truncated pyramid and the lower base edge is 24 cm. The upper base edge naman is 14. And the lateral base edge is, whose lateral edge is 13 centimeters. So, lateral edge natin is ito. Okay, ano daw pinapahanap? We need to find the lateral surface area. I write it here, LSA, the TSA, and the volume of this pyramid. Okay? Ito lahat ang magiging unknown natin ngayon. So, lateral surface area basically is nandito tayo sa gilid. Tama? Meron tayong nakikitang 4 na trapezoid dyan. I will write it here for letter A. Draw ko ngayon yung trapezoid na nakikita natin. Ito yon. Alright lang ha. Alright. Yan. So, this would be 14 centimeters. And this is 24 centimeters. Ito yung 13. Tama? And if you are to get your lateral surface area, what you need to do is to get 4 areas of trapezoid. Tama ba ako? 4 areas ng trapezoid. But for areas ng trapezoid, di ba, meron tayong, anong formula natin? 1/2 B1 plus B2 times your altitude H. Right? And H natin is not your 13 centimeters here because this is the lateral edge. Altitude H should be ito. H. Ito dapat si H na yan. And how are we going to get that H? Drop ko ngayon itong line na yan dito. So, bali, itong gitnang ito, tama ba sabihin na 14 to, no? 14. Since 24 to minus 14, you have 10. Divide mo by 2, you will have 5 centimeters here and another 5 centimeters there. Alright? So, clear na yon. Then, 13 dito, may 5 ka dyan, you can get your h via your Pythagorean theorem. So, how much is our h? Lagay ko dito ha. H natin is square root of 13 squared minus 5 squared. And that's equal to 12 centimeters. So, we can compute now our lateral surface area. That would be, ilan yun? Okay, ilan yun? 4 times 1/2 times, B1 is 14 on this side plus 24 on the downside here, and H natin, na-compute natin as 12. So, multiplying that, that's 4 times 1/2, 14 plus 24 times 12. Okay, 912 centimeters squared. And if the video is so fast, you can slow it down or you can check it again, what I'm trying to say here. So that's for the lateral surface area. Okay, so ayun yung lateral natin, no? Lateral kasi is around, nasa paligid lang, no? Yan, 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 yan. That's it. Ano lang kailan mo tandaan? Yung pag-compute ng H. H is not 13, but H is 12 from our computation. This is for letter A. For letter B, that's a bit easy, total surface area. So, kung total surface area, that's your lateral surface area, yung nasa paligid, plus the top area and the bottom area. Right? Area top plus area bottom, which both of these figures are squares. Alright, so we have PSA, LSA is 912 plus top area is 14 squared for a square, and bottom area is 24 squared. That would give us how much? 912 plus 14 squared plus 24 squared. 1684. cm squared. Okay. So that's it. Okay. Then last question is, what is the volume of this frustum? The volume of this frustum, that is a bit challenging because of a certain variable that we need to compute. Right here. Yan. So, kung meron tayong frustum, paano mo ba masasabi na frustum ang isang figure if you have similar bases that are parallel to each other? A square base on top, another square base at the bottom, and both of them are parallel to each other. Okay, you can have that as a frustum. How do you compute for that volume? That's H over 3. Let me have it as H sub O again, so as not to confuse you with the other H that we have already computed kanina na 12. So that's H over 3 times A1 plus A2 plus the square root of A1, A2. Wherein your A1 and your A2 are the top and bottom areas. Okay? We need to identify properly what is H sub O. H sub O. Let me erase this one here. H sub O is the distance between the bases. Okay, perpendicular distance to be more specific. perpendicular distance between the bases. So you might be asking, is that equal to 13? The answer is no. Is that equal to 12, which is this value here? The answer is still no. Take note, 13 is the lateral edge. It is a slant edge here. And 12 is here, perpendicular distance to the side, right? Okay, so another 12, I can drop another 12 here. That's 12. This one is 13. This one is 12. Okay, but what we need to find here is something that is perpendicular to this 12. Okay, and perpendicular to this height here. Okay, let me move that a little bit. Ayan. So that is H sub O. So if I am drawing this one on a side view, parang somehow makikita mo na nag-i-intersect itong 12 na to at saka yung H sub O. But again, para ma-imagine nyo siya ng maayos, no? Nakaslant kasi siya, nakaganyan. Yung pinakadulo na nakaganito, yun yung 13. Ito naman yung 12. Hinahanap kasi natin is ito. Directly ito. Okay? Distance of the upper base to the lower base. That is your H sub O. And how are you going to get H sub O? So, pwede mo siya gamitan ngayon ng Pythagorean theorem ulit. Okay? Anong Pythagorean theorem kaya ang gagamitin natin for this one? Alright. Sige. Idodraw ko ngayon yung bottom section. This one is our bottom section. What you are seeing here is, andito yung termination ng 12 sa side na to. Itong side na to. This one and this one are, ayan. Okay? And yung termination ng H sub O is here. So, it's going right at the top of, or right below the upper base. Ito yan na. Ang termination ng 13 is nandyan. So, I hope hindi na kayo nako-confuse kung nasaan si sino. Alright? So, what we need to do now is we get this distance. Naalala niyo pa ba itong distance na to? At saka ito? Sa computation natin kanina, no, that is actually equal to 5. Kasi diba, dadrop ko ulit dito ha. 14 ito pag dinrop mo siya dyan. And 24 minus 14 would give you 10. This one is 10, this one is 5, and this one is 5. That would sum up to 10. The excess of 10 would give you 5 and 5 here. So that means this one is 5. And this one is another 5. Okay? So if that is 5 and 5, can I get this one now? What would that be? 5 square root of 2. Right? Kasi 5 din ito. Oh, by Pythagorean theorem mo yan siya kukunin. 5 squared plus 5 squared, taking the square root of that would give us 5 square root of 2. Oh, hindi na siya magkasya. Arrow ko siya. 5 square root of 2. Now, I would like to draw this line here. The 5 square root of 2, I will draw it. This one is our H sub O. So, drawing na to. Ito yun, no? 5 square root of 2, H sub O, which is actually perpendicular yan siya. And this one is your 13. I hope you are following. So, given that, we can get our H sub O. Right? By Pythagorean theorem. That H sub O is the square root of 13 squared minus 5 square root of 2 squared. That would give us an H sub O value equal to square root of 13 squared minus 5 square root of 2 squared. Square root of 119. 119. Okay? So, may square root of 119 na tayo. We can compute the volume of the frustum now. Lagay ko muna dito ha. Ang A sub 1 natin is the volume or the area at the top. 14 squared is 196. And A sub 2 natin is volume at the bottom. That's 24 squared. Equal to how much? 576. Now, computing our volume, this would be square root of 119 divided by 3 times A1 natin. How much is A1? 196 plus 576 plus the square root of 196 times 576. Volume therefore is how much? Square root of 119 over 3 times 196 plus 576 plus the square root of 196 times 576. That is 4,028. 4,028.95. Do we have a unit? cm cube. So this is the volume of the square frustum that we have sa ating problem. So you have a lot to take note, but plain na mga formula ang ginagamit natin dito. No? The Pythagorean theorem ang pinaka ginagamit. Okay, we have a problem here. This is your Pappus theorem. Very important theorem, especially sa higher mathematics or higher na mga design subject na. Okay, ayan. Si Pappus theorem was actually the theorem na ginamit to derive your surface area ng mga formula and also your volume formula sa mga 3-dimensional figures natin. So, ano bang sabi ni Pappus theorem? Dalawang theorem kasi yung meron dito. The first one is the surface area theorem. Okay, ang sabi ni Pappus, if you have a line, say this is a line here, with a length L, and you are to rotate this line into a point or into a line with perpendicular distance equal to R. Okay? Ano daw ang mabubuo mo dito? So, halimbawa, ito is isang isang line lang with length, say, ilang inches ba to? Mga 5 inches. And then, i-rotate ko siya dito sa point na to. Rotate mo siyang ganyan. And if you are to follow the path of the rotation, what you will get is isang manipis na strip na paikot, on which kung ilalatag mo daw siyang paganyan, it will create an area. One-dimensional line, i-rotate mo, will create a two-dimensional figure with an area. And how are you going to get the area of that line, the area of the figure na na-form mo? Yun yung sabi ni Pappus. Your surface area daw is the length of the line that you will rotate times the length of the path of rotation. So in this case, kung iikot mo siya ng full circle, you will have a length na circumference equal to the circumference. So it's like ito yung L distance mo on a top view and ito yung point of rotation mo. No, let's say point O ito. Ayan. Ito naman yung distance R natin. So kung i-rotate mo siya ngayon, makakabuo ka ng bilog. If i-rotate mo siya in a full circle. Okay? So kung ilalatag mo daw yan, meron kang makukuhang ganito kahaba. Here is your length L na inikot mo. And this distance here is the circumference of the circle. 2 pi r. So that the area of this figure is L times 2 pi r. Yun yung sinasabi ni Pappus. Length times this path of rotation will give you a surface area. Okay? So, kung sabihin natin na hindi mo siya inikot ng buo, generally speaking, meron ka lang theta over 360 dito. Halimbawa, inikot mo lang siya ng 1/4. Hanggang dito lang, no? From this point here, inikot mo lang siya hanggang dito. So, hindi buong circumference yung makukuha mo, but only 1/4 of the circumference. O, ganun din pag kalahati, 1/2. Ganun din pag inabot mo dito. Or ganun din pag irregular, no? At a certain angle mo lang siya inikot. So, you need to parang designate that properly using this theta over 360. Alright, that's the surface area theorem, the first theorem of Pappus. The second theorem naman pertains to our volume theorem. So, erase ko muna to. Okay. Volume theorem naman natin to. Ang sabi ni Pappus sa volume theorem natin, if you have here an irregular shape, tapos iikot mo siya at a certain axis, i-rotate mo siya at that position there or at a certain point, ang mangyayari daw is makakabuo ka daw ng 3-dimensional figure. So, halimbawa, ito, iikot mo siya at that position there, para kang makakabuo ng donut, na ang cross-sectional area niya is ganito. Okay, since 3-dimensional figure na yun, you will be able to get the volume. You have an area here, and this is your point or axis of rotation, and you need to get this distance r. Ang distance r na to is from the centroid of the area you are rotating towards the point of rotation. This is your r. Okay, so the volume mo daw would become your area times the path of rotation 2 pi r pa rin. If hindi mo naman siya full circle rotate, meron tayong pi over 360. So this is a general lang na assuming ito na hindi sila nag-overlap, yung mga sections na hindi nag-overlap sa each other. Kasi 'di ba may mga portion na minsan nandito na yung area sa may axis of rotation. So kung i-rotate mo siya, merong volume na duplicated doon. But itong kay Pappus, parang general ito na hindi natin muna i-consider na nag-overlap yung ibang portions ng naro-rotate natin. Okay? So, that's for our Pappus theorem. And we have one problem here. Yan. So, this is a practice na pag nagko-compute kayo kasi mostly when I took my board exam, I remember under statics na topic, moment of inertia, computation of centroid, ganyan, nagagamit ko din to. Okay? So, determine the volume of the solid form if you rotate the figure shown in, if you rotate the figure that is shown in my drawing here for an angle of, let's say, 35 degrees. Okay? So, we have here line 1. This is our axis of rotation. Yan. Tapos, meron tayong 5 meters na distance dito. Tapos, we have a figure here. Okay. Then, yan. Ito yung figure natin. This one is, chop ko muna siya ha. So, this is 12 meters. This one is 6 meters. Ito naman is 3. And this is 3 meters as well. Tapos, 3 meters dito. Tapos, ito, 3 meters ulit. Okay? We need to get the volume daw. Rotated daw siya at an angle of 35 degrees. So, if titingnan mo siya sa top view, ito yung line 1 mo, na nandito yung line 1 mo, nandito yung, say, area mo, sa portion na to, ang centroid niya, ganun lang ang ikot mo. Hanggang dyan lang sa point na yan, 35 degrees lang. Siyempre, may mabubuo pa rin siyang 3-dimensional figure kasi umusog siya papunta doon. Tama? Ano? Anong sabi ni Papus? Ang volume mo daw is yung total area times 2 pi r. Ang area nito, mabilis yan makompute. Right? Can we get the area of this one? O, area total muna. Area total is we have 1/2 base times height. Base is 6 of this triangle. Height is 6. Base times height. Plus length times height. 3 times 6 plus, ito ikakat ko na lang, 3 times 3 plus 1/2, base is 3, height is 3. So that area total would be 36 times 0.5 plus 3 times 6 plus 3 times 3 plus times 0.5. That would be 49.5. Square meters. Next naman is kailangan natin kunin si centroid, r sub c. Ito, no? Okay? How are we going to get our r sub c? Ayan, paano ba natin kukunin ito ngayon? Pwede natin gamitin yung tinatawag na Varignon's theorem. Isulat ko dito yung area, guys, ha? Sulat ko yung area dito na total. That's 49.5. Para magamit natin yung space down there for our Varignon's theorem. Sabi ng Varignon's theorem natin, is your area daw, area total times your r sub c, lagay ko na lang, that's your centroid, is equal to the summation of the smaller areas times your r. Kada isang r daw nila with respect to our line of reference dito. So, mangyayari ngayon is iti-table siguro natin para hindi tayo mahirapan, no? Okay? 1, 2, 3, 4. We have 4 sections. So, ilagay ko muna dito bago natin isamak mamaya. We have area A and we have distance R bar. Okay, makinig kayong lahat. You have area of this first is 1/2 base times height. Okay, please follow. 1/2 0.5 times 6 times 6 na pataas. That's 18. That's for 1, 2, 3, 4. Label ko 1, 2, 3, 4. And then, ang distance niya, the centroid of this one is located here. Papunta dito. This will serve as our R sub 1 bar. R sub 1 bar is 2/3, ito, diba? 2/3 ng triangle. If nare-recall niyo yung formula ng ating centroid, 2/3 of 6 is 4 plus 5, that is 9. 2/3 of 6 plus 5 is equal to 9. Second natin na area would be 3 times 6. That is 18 pa rin. And the distance would be gitna papunta dito. That's R sub 2. That's how much? 0.5. 1.5 plus 6 plus 5 is 11. That is 12.5. Alright? Third area natin is 1/2 base 3 height 3. That's 0.5 times 3 times 3. 4.5. And distance, R sub 3 natin is from here to here. R sub 3. That is 1/3 of 3. 1/3 of 3 plus 3, 6, and 5 is 9 and 5. That's 14. So this would be 15 in total. And lastly, you have 3 times 3, 9 as our area. And distance R sub 4 is here. So R sub 4 is 1.5 plus 3, 6, and 15. As 3, 6, that's 9 plus 5, that's 14, 15.5. So, ito yung gagawin natin ngayon, no? Area total is 49.5. 49.5. R sub C is what is unknown. That's the centroid of the entire figure with respect to this one. Okay? Summation of area times R. So, that would be 18 times 9 plus 18 times 12.5 plus 4.5 times 15 plus 9 times 15.5. That would give us R sub C value equal to, let's compute, 8 times 9, 18 times 9, 18 times 12.5. Okay, that should give you 594 divided by 49.5. R sub C is 12. Okay? R sub C natin is equal to 12. Now, we can compute for our volume as our final answer. So, volume, sabi ni Papus ulit, is area total. Volume is area total, which is 49.5 times your 2 pi R sub C is 12. And don't forget, i-rotate mo lang siya ng 35 degrees. So, that should be 35 over 360 degrees lang. Right? So, 49.5 times 2 pi times 12 times that is 362.85 cubic centimeter. So, ito daw yung volume ng ating solid of revolution. Ayan. So, ulitin nyo lang if meron kayo hindi naintindihan sa portion na yan.